So in 11.2, we're going to talk about arcs and chords. Before we get to those, we're going to talk about what a central angle is. And a central angle for your circle is the angle whose vertex sits on the center of your circle. So the central angle we have here for this example is angle DOG. Central angles have vertices who sit on the center of your circle. Now when you take all of your central angles in your circle and you add them all up, the sum of those central angles with no interior points being in common, so we've got this central angle DCB, DCA, ACE, and ECB, all four of those central angles, when I add up all of their degrees, I'm going to end up getting 360 degrees, and that's something good to know for later on. So every central angle that we work with separates a circle into two specific arcs. So I've got central angle ABC here, and it splits it up into two arcs. The first arc we're going to talk about is arc AC. And the arc AC is actually a minor arc for this circle. And when we talk about labeling this minor arc, any minor arc, something smaller than like 180 degrees, what we're going to do is we're going to use the two endpoints for this arc. So A and C, and we're going to put a little arc symbol above it. So if you're dealing with a minor arc, you're going to end up using the two letters with a little arc above it. If I talk about the major arc in this case is the one that travels all the way from A through D around to C. We call this one my major arc. And the major arc will consist of all of these points, the endpoints, and then all of the points to the exterior of my angle ABC. So what we would do, if I need to know that we're talking about this arc instead of my minor arc, I'm going to actually use three letters to name it. So we would say arc ADC. So you always want to pick another point that sits in between the endpoints of that arc to make sure you're telling me it travels through it. So arc ADC, you use three letters to name your major arc, you use two letters to name your minor arc. Now when we take a look at arcs and their measurements, you actually want to pay attention to what the corresponding central angle's degree measurement is. So in our example here, we know that I'm working with angle PCM, and that central angle has a measurement of 110 degrees. If you're talking about the measurement of the arc, the minor arc that is formed by that angle, the minor arc's measurement will match the angle degree measurement for the central angle. So if my central angle was 110 degrees here, the measurement of my arc is also going to be 110 degrees. Now, the measure of any minor arc that you're working with, since a minor arc is the smaller of the arcs, that's going to be less than 180 degrees. The measure of any major arc is going to be greater than 180 degrees. If I'm talking about 180 degrees, that's actually a semicircle. And a semicircle is when I'm working with the diameter of my circle, and that diameter splits the circle into two congruent arcs. So you can kind of think of it that way. And when you name a semicircle, you are also going to use three letters to name that when you're naming the arc. So make sure that you're using three letters when you're naming the major arc and semicircles, and two letters when you're naming the minor arcs. So just to kind of recap that, the degree of your arc measure. Well, if I'm talking about the minor arc, the measure of any minor arc is actually going to equal the measure of my central angle. And then that means that the measure of any major arc that we're working with is going to actually be 360 degrees minus the measure of my central angle to give me the measure of that major arc. And remember, the measure of a semicircle is 180 degrees. So I know right now the measure of arc PM, that's the minor arc because that has two letters, is going to be 110 degrees. If I'm talking about the measure of arc PEM, that is going to be 360 minus the measure of arc PM. And the measure of arc PM was 110, so if you take 360 minus 110, you will be left with 250 degrees. You should probably put degrees on those. Next, for the next example, we're talking about a circle graph. And the circle graph shows all the different types of possible grasses that would be planted in the yards of one neighborhood. I want to figure out what would the measurement for arc KLF be. So from K to L to F. I want to figure out what the measurement of that arc would be. Now when I'm looking at this circle, I notice that is my centipede graphs. And the centipede grass takes up 65% of this entire circle. Now wouldn't you know that if you had a circle and it has 360 degrees, if I wanted to figure out how many degrees I could possibly have out of this circle that would represent 65% of my circle, I would take 360 and I would multiply it by 65%. Now we know as a decimal, 65% is 0.65. So if you take 360 and multiply it by 0.65, you're going to end up getting 234 degrees. So that's how I ended up figuring out what the measurement for my major arc was. And it makes sense because this arc is over 180 degrees, and major arcs should have measurements that are greater than 180 degrees. Now, using our previous example as reference, let's go ahead and take a look at this one. What I'd like for you to do is I'd like for you on your own to try to figure out what the measurement for the angles are and the given arc. Go ahead, pause the video, do this on your own, and when you're ready, start the video up again, and I'll have the answers written for you, and we can walk through it together. All right, so taking a look at this one. If we start off with angle FMC starts from this blue over to this yellow. So I've got angle FMC, and I notice it covers three portions here. So we've got pop, country, and R&B. Now, we know pop is 9%, country is 10%, and R&B is 11%. If I want this whole angle, that means I want all of that. So if I took 9% plus 10% plus 11%, we're going to end up getting 30%. So if you take 30%, so if I did 30% or 0.3 of 360, that's how I get the 108. That's how I know my angle FMC is 108 degrees. For the next one, we're talking about arc AHB from A to H to B all the way around. I notice that that's going to cover 75% of my circle. So if you do this, 0.75 or 3/4 of 360 degrees, that's going to end up giving you 270 degrees. So that's what I got for my arc AHB. The last one, if I'm talking about angle EMD, E to M to D, that's only the country section, and that's 10%. So if it took 0.1 times 360, that's how I got the 36 degrees for that one. So hopefully you remember from first semester something called segment addition postulate and angle addition postulate. With those postulates, what it was really saying is if you take two segments and you add them together, you should get the third whole segment. In my class, I told my students it was part plus part equals whole. Maybe you heard that on the video. The same thing can apply to arcs. If you're talking about the arc addition postulate, you can tell me that if two arcs are adjacent to one another, then if you add them up, you should get the whole entire third arc's measurement. So in our case here, we've got arc PQ. That's the smaller arc. That's a minor arc. If I add it to the minor arc of QR, shouldn't I get the measurement for the whole entire arc PQR, the major arc? So part plus part equals whole. The small one plus the small arc should equal the measurement of the entire major arc. Using that, we're going to go ahead and apply that information to our example. In this example, we've got circle Q, and it's telling me AC is a diameter, which is huge because it's telling me that A through C and ADC, those are two semicircles. The other thing they're telling me is angle Q or CQD is 40 degrees, so I'm going to label that with a 40. If I need to figure out the following information, let's talk about arc CD. So arc CD here should equal the same exact measurement of the central arc that forms, or the central angle that forms that arc. So arc CD is going to be 40 degrees. The next one asks you to figure out what is the measurement of arc CAD. Well, I notice that's the major arc, and it takes up everything except for the 40 degrees here. Since there's 360 degrees in a circle, you're going to take 360 and subtract off the minor arc's measurement of 40 degrees to get 320 degrees. For arc AD, from A to D, what I notice is from AD to C, that's a whole 180 degrees for a semicircle. I don't want the whole semicircle. I want 40 degrees less of it. So I would take, to find out the arc AD, the measurement of that arc, I would take 180 and I would subtract off the 40 that I had already, and that would give me 140 degrees. The last arc I have to work with is arc DCA. Now in this case, I know that CD, that arc is 40 degrees, and I also know the arc from A to C in this case is 180 because that's a semicircle. So I would use the arc addition postulate and do part plus part equals whole. So I would take 40, add it to 180, and this arc would be 220 degrees. Now in this example, we're giving you circle C, and they're also telling me that IL is a diameter, which is really important because that tells me I've got two semicircles here, and semicircles have 180 degrees. That's really, really helpful, especially if I'm going to try to solve for X, and I'm also going to try to solve for the arc measurement for ILR. So for the first one, let's go ahead and set up for X. I notice that if I'm looking for X, this is a 13 here, I notice this part here, this angle is 3x plus 13, and this angle is x minus 1. Now with those two angles, if I put them together, notice they're a linear pair because they form a straight line. So I add them, and I'm going to set it equal to 180 degrees. So if you take 3x plus 13 plus x minus 1, it's going to equal 180 degrees. Now we're going to solve this, right? So I put like terms together, I get 4x plus 12 equals 180. 4x is going to equal, because I'm going to subtract my 12, I'm going to get 168. And when I divide, I'm going to get x equals 42. Oh, if x equals 42, I can take that value and I can plug it in. And when I plug it in, I'll end up getting 42 minus 1 gives me 41 degrees for that one. And then the other one we're going to end up getting is going to end up being 3 times 42 plus 13. I should end up getting 139. Now, if I'm asking you to find the measurement for arc ILR, I'm going to take I to L, that's 180 degrees because it's a semicircle, and I'm going to add on to that 41. So if I take 180 and add on the 41, I'm going to end up getting 221 degrees. Another way you can do this is you can take the fact that you know there's 360 degrees in a circle, and you can subtract off the arc you don't want. So if I took 360 and subtracted off 139, I would still get 221 degrees.